With 4.5 billion passenger trips taken each year and more than 16 million planes taking off annually in the US alone, commercial airlines provide affordable travel on a global scale. But the aviation industry has a big issue: emissions. Aircraft are responsible for 2.5% of global CO2 emissions, and the problem is growing.
Aviation is one of the few sectors whose emissions are actually set to grow as opposed to decrease over the next few decades.
To combat this, the industry has agreed to try and achieve net zero emissions by 2050.
We've seen a much bigger push from airlines and from companies throughout the aerospace supply chain that in the long term, the biggest challenge facing the industry is emissions.
The airlines are constantly asking the manufacturers, we want to burn less fuel. It's not just about being green, it's millions of dollars difference any fuel savings that they have.
Electric aircraft are being explored, but until more energy-dense batteries exist, they are limited in range.
You can't carry enough batteries to sustain flight because they're just too heavy, even with the next generation of batteries, unfortunately.
But there could be a solution that rivals the power of fossil fuels without the negatives: hydrogen. Hydrogen has the highest energy per mass of any fuel and doesn't release any emissions.
Hydrogen is about 3 to 4 times lighter than jet fuel on an equivalent energy basis. In fact, it is the lightest weight energy carrier outside of nuclear fuels. This is why hydrogen already gets used as a fuel in space launch.
The promise of a zero-emission plane that could compete with jet-fueled aircraft has everyone from big players like Airbus to new startups exploring the technology.
There's been some successful flights, in fact, but it's all been on small regional aircraft.
And with the aviation market expected to grow, this new technology could represent a big opportunity.
We have today $1.5 trillion market that we are transforming and we need to transform. The growth rates are some of the highest of all transportation types.
All the technology is here today. Now is the perfect time to use hydrogen to overcome this issue of climate change.
Hydrogen in aviation has been around for decades.
The Department of Defense looked at hydrogen-powered aircraft back in the late 1950s.
The Soviets actually flew an airliner, the Tupolev 155, in 1988 on hydrogen. And there have been a couple of smaller aircraft flying on fuel cells in the early 2000s.
To power an aircraft, it can be used in two ways.
Hydrogen can be used to directly power the turbines, it can just be burnt, or it can be used in conjunction with a fuel cell that's creating electricity.
Hydrogen fuel cell, they are, at least currently, more efficient than hydrogen combustion engines.
And while hydrogen is expensive today, over time it could be cheaper than conventional jet fuels.
Fossil fuels depend on ever more expensive extraction. Contrast that with green hydrogen, which is produced from renewable electricity that has pretty much zero marginal cost, and the fully loaded cost is constantly reducing.
The Inflation Reduction Act, passed in the summer of 2022, provides renewable energy and clean hydrogen plants a tax credit of 2.6 cents per kilowatt hour and up to $3 per kilogram of hydrogen through 2032.
If you factor in the IRA and the escalated oil prices today, green hydrogen is already superior to jet fuel in terms of cost. But even if you take out the subsidy and you take out oil price shocks as maybe transient effects, we would expect there to be parity just on the basis of falling renewable electricity prices.
However, the nature of hydrogen does make it tricky when used in an aviation environment.
Hydrogen does have a little bit of an Achilles heel, which is volume. And you can't put it in the wing of the airplane.
If you store it as a gas, it takes up an enormous amount of volume. If you have to store it as a liquid, you're storing it minus something like 425 degrees Fahrenheit.
There are a lot of durability challenges with fuel cells. What happens when the aircraft tilts and rolls? The fuel cell has to stay humidified, and that can be a challenge.
Numerous companies are experimenting with hydrogen technology, with the biggest being aircraft giant Airbus.
Airbus has been looking at hydrogen for a long time, and within the last years has increased that focus, looking at both hydrogen fuel cell and hydrogen combustion, and also a hybrid configuration between hydrogen fuel cells and combustion.
Airbus is looking at hydrogen currently through several different initiatives. One of them is the Zero-E aircraft that they are trying to develop, and that would be more of a hybrid model where it is fueled by hydrogen and also traditional combustion engines. Outfitting the A380, its biggest airplane, the biggest commercial airplane that's out there, adding on a hydrogen engine.
For this test, it's working with engine maker CFM International, a joint venture between GE Aviation and Safran. CFM is working on a new design they say could cut emissions by more than 20% of today's levels and be compatible with sustainable aviation fuel and hydrogen. When first announced in 2020, Airbus projected its hydrogen concepts could enter service by 2035.
They've walked that back a bit, and they don't have current, an announced program that the next aircraft will be flown using hydrogen or anything like that.
ZeroAvia, founded in 2017, is a UK-based hydrogen-electric aircraft startup that has raised $140 million from airlines and notable investors.
United, American, British Airways, Alaska Airlines, Shell is one of my major investors, and they're the largest jet fuel supplier today. They're looking to provide all the hydrogen as well.
The company is focused on building hydrogen-electric propulsion technology.
First and foremost, we're engine developers and manufacturers. We also bring infrastructure to the airports with partners. We've pre-sold $10 billion worth of our engines.
It flew its first prototype in 2019 and performed a test flight of its full-size model in early 2023.
20-seat aircraft, full-size engine, representative of our launch platform. We actually have done 4 test flights already on that platform.
The fact that ZeroAvia had a successful test, that is a huge leap forward. And the next step with that is it's more testing.
It's hoping to bring a 10 to 20-seat aircraft to market by 2025, with plans to release a 70-seat aircraft in 2027.
We've set up 7 aircraft manufacturers as partners, including our launch partner, Textron, which is the world's largest manufacturer of small commercial planes. The larger engine, we already have a lot of tests that were done on the technology around that.
Universal Hydrogen, founded in 2020 and based in Hawthorne, California, is another upstart working on hydrogen planes. It is led by Paul Uramenko, former Chief Technology Officer at United Technologies and Airbus.
I've worked with a broad range of technologies from batteries to biofuels and synthetic fuels to hydrogen, and came to the conclusion that hydrogen is probably the best answer.
The company has raised about $100 million to date.
Our Series B round was led by Tencent. We have Airbus as a strategic investor. We have GE Aviation. We have American Airlines, as well as JetBlue. We also have Toyota.
It's developing both the hydrogen fuel infrastructure and the technology to retrofit aircraft.
So this is our hydrogen fuel cell powertrain test bed. We have 6 fuel cells here providing nearly 1 megawatt of fuel cell power. And then we have a 750 kilowatt electric motor at the very front of the Iron Bird. And this simulates our aircraft powertrain. And this is where we vet all the technology on the ground before we integrate into the aircraft.
For its retrofit, it chose to start with the ATR-72, a 50 to 60 passenger regional plane.
It takes about 2 megawatts of power on each side of the airplane to power that aircraft. And so we partnered with Plug Power, and we created a conversion kit that replaced their existing jet engine with a fuel cell and an electric motor.
Universal Hydrogen successfully conducted a test flight of this aircraft in March.
We only converted one side of the airplane. We kept the other one as a conventional engine for safety of flight. And that is the largest airplane ever to fly on hydrogen fuel cells. And we were in fact able to throttle back the jet fuel powered engine and was able to cruise exclusively on hydrogen power.
Universal Hydrogen is planning to test later this year with liquid hydrogen, and that's a really important step too, because liquid hydrogen has a much higher density.
The company is aiming to bring its conversion kit to the market in late 2025. It says it already has several customers and is planning to launch with US-based Connect Airlines and Amelia, a regional airline in France.
We have 16 customers to date, across whom order book totals 247 airplanes. So that's about $1 billion order backlog for airplane conversions and a little over $2 billion in hydrogen fuel services over the first decade of operation.
Realizing the vision of hydrogen planes won't be easy, and experts believe that proposed timelines are ambitious.
It could be years before we actually see this flying commercially.
Given the technology constraints of fuel cells, it may only be viable for small and medium aircraft.
The infrastructure required to power a plane with it could take up a lot of room. One thing that airlines might have to do is take seats out.
Given the cost of hydrogen and the reduction in seats, flying on hydrogen will be more expensive than jet fuel unless there are carbon taxes that increase the price of flying with current jet fuel.
Competing with larger engines is challenging as they operate more efficiently.
What you're competing against actually is getting better.
And that's where the majority of the pollution in aviation comes from.
Large commercial airplanes, the typical airplanes that are flown by airlines in the world, they emit about 93% of the carbon of the industry.
You have to go to a hydrogen combustion type approach with a regular jet engine that's just adapted for hydrogen.
Once the technology is validated, it could take several years to get through regulators.
There is a really high bar to getting any of this technology approved. Even with very conventional aircraft, it can take years to get through regulators.
Another major hurdle is building out the infrastructure for hydrogen fuel. Universal Hydrogen is aiming to address this by leveraging standardized cargo modules.
Our idea was, let's put hydrogen in these modular capsules. They plug directly into the airplane and become the primary fuel tank for the duration of the flight.
We're looking at a liquid hydrogen module. These fit perfectly in ISO standard shipping containers, and then we can use the existing intermodal freight network to transport hydrogen to airports around the country, around the world.
We see the total addressable market for fuel services, which is our core business as a company, as about $2.5 billion a year.
And there is the issue of hydrogen production itself. In order to leverage its benefits, hydrogen needs to be synthesized with zero carbon emissions. Currently, 98% of hydrogen is made in a way that uses fossil fuels.
Green hydrogen is where you actually use a reusable source, wind energy, solar energy, to make hydrogen. But today, that doesn't really exist in any significant volume at all.
I have spent much of my career studying the alternatives. I've done a lot of work on battery-powered electric aviation. I've done a lot of work on what are so-called sustainable aviation fuels. There just isn't another option.
You need to move to the sustainable energy source sooner or later. And once you do the analysis, the only way you're going to do this is going to be through hydrogen.
I personally have done all the trace studies and numerical analyses. Smarter people than I have also done these studies and vetted these calculations. And we all firmly believe that this is a viable option to decarbonize aviation.